When we look up at the night sky, we often imagine alien life as something familiar, beings walking on solid ground much like us. But the universe is far more imaginative than we are. What if life doesn't need land at all? What if it thrives within a world, not on it? That's the tantalizing question that brings us to Jupiter. The search for extraterrestrial life challenges our assumptions and expands our definition of what it means to be alive. We've sent probes to scan distant worlds, but maybe we've been looking in the wrong places, or with too narrow a focus. Life could be hiding in plain sight, in a form so alien we might not even recognize it. Consider the possibility of life in the clouds. On Earth, our own atmosphere teems with microscopic organisms swept up by the winds. Now, imagine a world where the atmosphere is thousands of times thicker, a world that is almost all atmosphere. Could such a place host its own unique form of life, born and living entirely in the clouds? That's the question that makes Jupiter so compelling. So, let's embark on a journey of imagination and science and ask, could there be life floating in the skies of Jupiter? Jupiter is a true giant, more massive than all the other planets combined. It's a gas giant, a colossal ball of hydrogen and helium with no solid surface. Its gravity shapes the orbits of asteroids and comets, acting as a cosmic bouncer for the solar system. Jupiter's face is a masterpiece of swirling clouds and perpetual storms. The most famous is the Great Red Spot, a storm so large it could swallow Earth and has raged for centuries. Descending into Jupiter's atmosphere, you'd encounter frigid cold, then crushing heat and pressure as you go deeper. The planet's layers are extreme, but somewhere in between, there might be a sweet spot, where conditions are just right. Jupiter's atmosphere is a complex system of zones, each with unique temperatures and chemistry. Scientists have identified a narrow slice of the Jovian sky where life might be possible, not on a surface but in the heart of the storm. This is where our search begins. The idea of life in Jupiter's atmosphere isn't just science fiction, it's a real hypothesis, first imagined by Carl Sagan and E. Salpeter in the 1970s. They wondered, how could life survive in a world with no surface and crushing gravity? Their answer, it would have to float. Sagan and Salpeter envisioned a complete food chain in the clouds. At the bottom were sinkers, tiny drifting organisms like airborne plankton, swept up by powerful updrafts before they could fall to their doom. Feeding on them were the floaters, enormous balloon-like creatures buoyed by hydrogen, drifting and filtering the air for food. And where there are grazers, there are predators, agile hunters jetting through the clouds in search of prey. This ecosystem, producers, grazers, and predators, shows that life in Jupiter's clouds is not just possible, but plausible. It's a world where biology is shaped by the need to float, not walk. The floaters and hunters would be as alien to us as anything we could imagine. Yet, in theory, such a system could work. On Earth, the Goldilocks zone is where a planet's surface is just right for liquid water. Jupiter, far from the sun, is cold and inhospitable, except perhaps within its own atmosphere. Scientists believe there's a Goldilocks zone inside Jupiter, a layer where pressure and temperature are surprisingly Earth-like. Here, temperatures could range from 0 to 20 degrees Celsius, and pressure is similar to sea level on Earth. This layer may contain clouds of water vapor and ice, key ingredients for life. Jupiter's internal heat drives powerful convection currents, mixing chemicals and energy throughout the atmosphere. These currents could sustain a biosphere, keeping life-bearing clouds circulating in the habitable zone. But this region is anything but calm. It's turbulent, with fierce updrafts and downdrafts. Any life here would need to avoid being swept into deadly depths or frozen above. That's why the idea of floaters and sinkers is so compelling. They're perfectly adapted to this dynamic environment. The constant churning could provide the very mechanisms that make an aerial ecosystem possible. What might Jovian life actually look like? Let's imagine the floaters, vast translucent balloons, city-sized, drifting through the clouds. Their skin would be thin yet strong, filled with hydrogen or methane for lift. Long, trailing tentacles could collect food, tiny sinkers and organic molecules, like living fishing nets. These gentle giants might glow softly, communicating with flashes of light in Jupiter's perpetual twilight. Hunters, in contrast, would be built for speed, arrowhead-shaped, armored, jetting through the clouds to hunt floaters. They might use sonar-like senses to find prey in the murky atmosphere. Sinkers, the foundation of the ecosystem, could resemble hardy bacteria or algae, surviving cycles of falling and rising, perhaps using chemosynthesis powered by Jupiter's lightning. Each organism would be a marvel of adaptation, shaped by the need to float, feed and survive in a world of endless storms. The possibilities are as vast as Jupiter itself. Life here would be unlike anything on Earth, yet still bound by the same laws of biology. Our ideas about Jupiter are grounded in decades of robotic exploration. The Galileo spacecraft dropped a probe into Jupiter's atmosphere in 1995, sending back data as it plunged to its destruction. It found extreme turbulence and surprisingly dry upper clouds, but also abundant lightning, a potential energy source for life. The probe's single measurement may have missed wetter regions, leaving the question of water open. The Juno mission, arriving in 2016, has revolutionized our understanding, mapping Jupiter's magnetic and gravitational fields and measuring water content. Juno's data shows Jupiter is even more complex than we imagined, with deep atmospheric bands and a lumpy magnetic field. Early results suggest water is more plentiful than Galileo indicated, especially near the equator, reviving hopes for a habitable zone. Juno's images of Jupiter's poles reveal clusters of cyclones, adding to the planet's mysteries. These missions haven't found life, but they've given us the data to refine our search. Each discovery brings us closer to understanding Jupiter's potential for life. To truly search for life in Jupiter's clouds, we need new probes, designed to survive, explore, and search for signs of biology. Future missions could include advanced atmospheric probes, mobile chemistry labs sniffing the air for organic molecules and biomarkers. As they parachute through the habitable zone, they'd analyze cloud composition in real time, searching for chemical imbalances that hint at life. Even more ambitious robotic flyers or aerobots, designed to navigate Jupiter's atmosphere. Imagine a robotic blimp or drone, riding air currents, sampling different regions, and searching for both microscopic and macroscopic life. These machines would need to be robust, autonomous, and able to generate their own power in a hostile environment. The challenges are immense, but not impossible. With continued innovation, a mission to hunt for life in Jupiter's clouds could become reality in the coming decades. Such a mission would be a true safari through the skies of a gas giant. The technology is within reach, if we dare to try. The next step in our search is waiting. Jupiter's influence extends far beyond its own clouds. Its gravity acts as a cosmic shield, deflecting comets and asteroids that might otherwise strike Earth. Without Jupiter, life on our planet might never have had a chance to flourish. Jupiter's gravity also shapes the orbits of its many moons, some of which, like Europa and Ganymede, are prime targets in the search for life. Studying Jupiter helps us understand the entire Jovian system: planet, rings and moons. It's a laboratory for learning how worlds form and how life might arise in diverse environments. When we study Jupiter, we're piecing together the story of our cosmic neighborhood. The king of planets is a cornerstone in our quest to understand the universe and our place within it. We've journeyed from imagination to hard data, exploring the possibility of life in Jupiter's clouds. We've seen that the laws of physics and chemistry don't forbid such life, if the conditions are right. Jupiter holds a temperate zone, water, organic molecules, and energy sources, all the ingredients for life as we know it. The story of Jupiter reminds us to keep an open mind in our search for life. Life on Earth thrives in the most extreme places. Why not in the clouds of another world? The universe may be filled with beings so strange they challenge our very definition of life. Each new mission brings us closer to an answer. As we gaze at the cosmos, we must ask, are we alone, or is the universe humming with life in forms both familiar and fantastically strange? The search continues, and it invites us all to look up and wonder,